Welcome to a fluids video, and this fluids video is going to be called head. To describe head, I'm just going to take a pipe. And in this pipe, I'm going to have some water flowing. And let's have the water flowing from left to right. And the way to visualize head is to imagine what would happen if we took a glass tube and inserted it into the pipe so that there was a hole in the pipe, and now water, in addition to flowing from left to right, could flow up. Would it? Yeah, the answer is yes. But it would only flow so high. See, there's pressure. Pressure is something that we call omnidirectional. That means, and this is a specific kind of pressure, it's called static pressure. But that means it's the same in all directions. So at this point right here, there's a pressure, a static pressure in all directions. And as we puncture that pipe, water is going to flow up until it will equalize. And we call that the head, the pressure head. So, what would the units be? Well, I would take my tape measure out and I would measure some distance. And that distance would have units of feet or meters. So if you've already watched the energy video, you can see there that the energy principle has units of head. Okay, so let's, in our pipe, look at a place down the way. I puncture the pipe again. And my first question is this going to go as high, higher, or not as high? Hopefully you said, it depends. You're right. But let's say that we put some friction in the pipe. If there is friction in the pipe between these 2 points, energy is being converted. And it's being converted to internal energy, and then that internal energy is causing a heat transfer. So energy is leaving this system. So the head won't be as high. And in fact, the name we have for that drop in head, wait for it, head loss. Head loss is a reduction in pressure due to fluid friction. There's an equation for head loss in a straight pipe. It is something called the friction factor times how long is the pipe times how fast is the water moving squared divided by the diameter divided by the acceleration due to gravity and divided by 2. You know that mnemonics are a thing. When I first learned head loss, we called it the fluffy squared over 2 dog. Fluff V squared over 2 dog. It has worked. It has worked as a mnemonic device for me. So the longer the distance between these two, the more head loss. The faster the water's flowing, the more head loss. The bigger the diameter, the less head loss. Because the head loss happens where the water touches the pipe. And as the diameter gets bigger, the surface perimeter ratio to the area gets smaller, so less head loss. And then a couple of constants. And this friction factor has to do with what is your fluid? Is it water? Is it oil? And what is the pipe made out of? Is it smooth? Is it rough? That all goes into the friction factor. All right, so this is head. This is head loss. Let's take a few more looks at head. What if we were to take our pipe, have our 2 tubes, and have some water flowing through it? What if we put a pump in the pipe? So I'm going to draw another one of these, and while I'm doing it, I want you to show where the water's going to go. Where do you think? If you said you think it's going to go higher, you are right. We've added energy to the system. And what do you think we call that energy we've added to the system? Good answer. We call it the pump head. P-U-M-P, we usually just use a P. So the amount of energy that the pump added to the system, we call the pump head. And now going out on a limb here, what do you think happens to the turbine? What do you think happens if we put a turbine there? Give you a second to, once you press pause, draw this. All right, you should be back. And hopefully you drew it less. You said, oh no, now wait a minute. If there's a turbine, we're taking energy out. The head will be lower, and we will call that distance the turbine head. One more. If I had water flowing in this system, and I put my pipe in, the water would rise to a certain height. But what if, and that would be due to the omnidirectional pressure head, what if I took my pipe and turned it that way so that the full-on velocity of the water is also pushing on? What do you think would happen? Do you think that this level would go up? It would. And it would go up an amount due to the velocity head of the water. We call that the dynamic pressure. Dynamic pressure. Pressure due to the velocity of the fluid. and the dynamic pressure head also known as the velocity head, measured in units of feet or meters. Okay, so that's head, head loss, pump head, turbine head, velocity head. I'm going to head out. Bye.